Guys, this is chapter 1 function. So let's start off with the idea of relation. You really learn some of this in your lower form that relation is a link between two sets of objects. So we can actually represent it using a couple of ways. Number one, we use what we call the arrow diagram. So for example, you can see a set of object given by set x 1, 2, 3, 4. It is mapped onto set y 4, 5, 6, 7. We call this an object, we call it image, but in IGCSE normally we just say the x value, the y value. So we say that set the x value here is mapped onto the y value. So now we can use what we call an ordered pairs to represent this data as well. Ordered pairs is written in this form, in the form of coordinates. It's like x followed by y. So 1 to 4, 2 to 5, and so on. And number 3, we can also use a graph method. Like if we plot it on the x and y axis, looks like a straight line can join together. Now, there are actually types of relation. We talk about relation, type of relation, right? So we can actually, let me draw it here. We can use an arrow diagram to represent it like this. For example, when one x value is mapped onto one y value, each. So we say that, so x is your y. We say that relation is a one-to-one relation. So we can also have multiple x value mapped onto, let's say put C here, a single y value. So we say this is a many-to-one relation. Now what if you have one x value mapped onto multiple y value? We say is a one-to-many. And lastly, if you have combination of one-to-many and many-to-one, we call it a many-to-many relation. So we have 4 types of relation: one-to-one, one-to-many, many-to-one, and many-to-many. Now, if you were to represent this on ordered pairs, it's a bit hard to see. Ordered pairs is very hard to see that relation. Arrow diagram can quite easily. Yeah. Another one is we can represent it on graph. Now, graph, we have different types of graph. I hope you really learn or know about different types of function. When we talk about a linear function, okay, I'll give you an example. A linear function is in the form of y equals mx plus c. You will know that, right? This is called, this type of graph has what we call a one-to-one relation. Why is it so? Well, because every x value here is mapped onto one y value. Okay, so we can draw a line vertically downwards, draw a line horizontally to the y and x axis. This is your y axis. You can see that one x value is mapped onto one y value. Another example of one-to-one relation is a cubic function. I'm sure you've seen this before, right? So let's say, but this is a simple cubic, y equals x power 3. Now cubic, we have different types of cubic. You can also have a graph like this, which you're going to learn later. This is not one-to-one. This is another type. This is many-to-one. So, but for x squared, x cubed, so this is one-to-one because one x value is mapped onto one y value. Now we can also have a reciprocal function like y equals to 1 over x. 1 over x is like this. One x value also mapped onto one y value. It's also a one-to-one relation. So all these are one-to-one. Alright? Okay. Example of many-to-one. Okay, what is many-to-one? Many-to-one, the classic one will be a quadratic. So we have a quadratic function like this. It can be in the middle, can be, yeah, let's say this is simple y equals x squared. So you can have two x values here, x1 and x2. They share the same y value. So 2x mapped into 1, y we say is a many-to-one. Okay, another example is one, we call this the truncus function, y equals 1 over x squared, like this. 2x value, x1 and x2 map onto the same y value. Okay, example of one-to-many. One-to-many, if I have y equals x squared, you know the graph looks like this, right? The axis is on the y, here, the reflection, axis of reflection is on the y. But if I change to x equals to y squared, so now it looks like this. And if you were to draw a vertical line this way, your x value here is mapped onto one y value here, one more y value here. So it's actually a one-to-many relation. Yeah, one-to-many relation. Okay, lastly, you can have what we call many to many. A classic example is what we call equation of circle. Equation of circle usually is in the form of x squared plus y squared equals to r squared. Or maybe I give an example, your let's say your radius is 2. Yeah? So this would be 4, 2 squared 4. Now you don't need to worry so much about the equation. Yeah? What we are interested in is the type of relation. So here one x value map onto one y value here, one y value. You see? One x with 2 y. So it's a one to many. Now at the same time, if you move across, there's another x value here. Let's say this is x2, this is x1, right? So this x value also map onto 2y value. So it's a one to many. At the same time, it's a many to one, right? So one to many, many to one. So that's why this is a many to many relation. Okay. So now let's talk about the type of function. Function is a relation for which every x value is mapped onto exactly one y value. That means you must have a one-to-one relation or many-to-one relation, as long as it has every x value has only one y value. So a quick one, have a look at this. Is this a function? Yes, sir. One-to-one is a function because every x value has only one y value, right? So it's a function. Is this a function? Yes. This x value has one y value. This particular x value also has one y value. So this is a function, this is a function. One to one is a function, many to one is a function. So how about one to many? Is it a function? No. Why not? Because this x value here, it has multiple or two y value. Yeah. In order for it to be a function, it must have only one y value. Okay. So finally, many to many, is it a function? No, because this has multiple y value. Yeah, remember, one-to-one and many-to-one, they're considered as a function. The rest, one-to-many, many-to-many, they are not function. Okay? Okay, we are supposed to state the type of relation. Okay, so we draw this a vertical line downwards. This is your x value. You have one y value here, one y value here. So it's a one to many relation. Okay. Oh, sorry. One more thing I forgot to tell you. One of the definition of function is this. Function is a special relation. Each x is mapped onto exactly one y value. Yeah. So now, is one to one a function? Yes. Is many to one a function? Yes. Now, I know some of you may be a bit confused. Why many to one is a function? I say each x value has only one y value. For example, look at this one. This is your x value. How many y value do I have? 1. How about this fella? How many y value? 1. So many to one is also a function. One to one is a function. Is one to many a function? No. Why? This x value has multiple y value. Your x must have only one y. Then it's a function. Is many to many a function? No. This x has multiple y value. Yeah. So the type of relation that is regarded as a function is one to one, many to one. Okay. The rest are not. Okay. Come back to this question. State the type of relation. Hence determine whether it represents a function. Does this represent a function? No. Not a function. Yeah. Only one to one and many to one is a function. How about this? I draw a vertical line. One x value move across one y value. What are relation? 1 to 1. Is this a function? Yes, a function. I will by picking a point. This is my x value. This is my y value. So what are relation? 1 to 1 relation. Is it a function? Yes, it is a function. You just write yes, Vidula, or function. Okay, how about this? This is actually called ellipse. Double L, I can't remember. Yeah, ellipse. Yeah, it's not oval, it's ellipse. So one x value has two y value. At the same time, this y value move across has another x value. So that means it's actually a many to one combined with a one to many. So that gives us a many to many relation. So is it a function? No, not a function. All these are something you done in your normal math. So I'm going to do quickly here. So what is F2? F2 means we put 2 inside. 3 minus 2 times 2. 3 minus 4, -1. How about this? Find the value of x for which fx is now -5. So you take 3 minus 2x, the result is -5. You can bring this over, you get -8. X is +4. Simple, right? Yeah, simple completion. Have you done this in your normal math? So you get 3 times -1 minus 5, answer -8. Second one, gx equals x. That means 3x minus 5 is x. Bring over 2x, bring over 5, x is what? 5 over 2. Okay? For quadratic function, right, this is also quite easier. H5 means what? You put 5 inside, you get 25 minus 10. What is 25 minus 10? 15. How about this? Find the values of x if hx is 8. My hx is x squared minus 2x. The result is 8. You need to, and guys, what can we do with this? Factorize, you know how to factorize quickly. This is 4, 2 minus and plus. X is minus 2, x is 4. Okay? Hurry up. F6 means we put 6 inside. What do you get? 36 minus 12, 24. Find the value of x for which fx equals to x. So x squared minus 12 equals to x. Bring over. Can you double bracket factorize? X 4 3 plus, sorry, minus first. This one is minus and plus -3 +4. Can you see? And these are, I have to include this because all these are past year questions. See? Yeah. October, November, paper 2, paper 3. Okay, so the first one, what is W -3? I'm going to put -3 inside. So you will get -9 plus 2 minus 7. This one is 1, answer -7. Okay, the second one, how do you find the value of x for which wx equals x? What's your wx? 3x plus 2, x plus 4. The result is x. So I can multiply over. This is x squared plus 4x. Bring over 2 is 0. Then you double bracket factorize it. My x is either 1 or -2. Okay? Yes? Okay, please do subtest. This is quite easy, right? Because this one is just a linear equation, no quadratic. F1 means you put 1 inside, so you get 4. 1 minus 3, answer -2. Okay, the second one. 4 over x minus 3 is -4. So for me, I'll bring this up, I bring -4 down. What is 4 divided by -4? Answer -1. I bring this up, I bring -4 down, again -1. Bring over x is now 2. Okay? Okay? See quadratic first. Now, you know that if I give you y equals x squared, it's center. Have you seen this before? This one you learn lower form, right? No. Yeah, y equals x squared looks like this. Now, number 2, what happens if you have a negative in front? Flip over upside down, right? It is now a maximum graph, we call it. This is a minimum graph, we say this is a maximum graph. Okay, number 3. Okay, 3 is not so important, but I just want you to know extra knowledge. If you have a 2 in front of x squared, how does it affect your graph? It's not moving upward, this one. Okay, for example, just see, when x is 1, your y is also 1. But now, when x is 1, y is what? Y is what? When x is 1, what's your y? Your y is 2. You don't actually move, you make the graph narrower. They are actually closer to y-axis. Right now, what is the difference between number 3 and number 4? Now, the graph is broader. Right? Before this, when x is 1, 2. Now, when x is 1, y is just half, isn't it? the graph is now broader. Okay, but actually broader, narrower doesn't really matter. When you draw, you cannot really tell unless you draw on the same axis. You draw a separate axis, you cannot tell it. Okay, more importantly, you need to know what happened when you have a minus 1 square. Now, my x initially is here at the center. The moment you minus 1, you are actually shifting the graph to the right by 1. Yeah. How do you know? Now, how do you know? Very simple. You know at x y is always 0. Now we take x minus 1 square equals 0. When you square root 0, you still get 0. X should be what? 1. Now, number 6. What is the difference between this and x plus 1 square? Now you move to the left by 1. Yeah. Okay, there's a name for this line. Do you know what you call it? It's called the axis of symmetry. There's a name for it. We call it the axis of symmetry. For quadratic graph, you have an axis of symmetry because you divide the line into 2 equal half. Okay, number 7, if you have x squared plus 3. This is your basic x squared. When you plus 3, you're shifting the graph up by 3. So the graph should look like this. Yes or no? You shift up by 3. Number 8, x squared minus 3. Now you shift the graph down by 3. Okay? Yes? Clear? Okay guys, so let's talk about example number 5. So in example 5, so what we need to do to find the range is to do a sketch of a graph. You see, you're given the domain of -3 to 2. That means we know for straight line it's very simple. We can just put -3 inside. 4 times -3. Okay, let me show you the working. So this is -12 plus 3, -9. And if I put 2 inside, you get 4 times 2 plus 3, which is 11. Alright? So what we can do is we can plot this graph. -3 minus 9 is over here. 2, 11 is over here. So if I join together, you can see it. It's a straight line like this. The smallest value you have is -9. The largest value you have is 11. So your range, remember range is your y value. Domain is your x value. So my smallest value of y is -9. The largest value is 11. So we can write our range as fx between -9 and 11. Okay, it's not difficult, right? Go through this review. For me, because this is a straight line graph, it's a linear graph, I put x and y. X is 0, y is -7, x is 6, 2 times 6 is 12, 12 minus 7 is 5. So I draw this 0, -7 here, 6, 5, let's say somewhere here. I just join together. Okay, can you tell me what's your range? Is your range alright? This is your domain, right? Domain is your x value. Range is your y value. So my smallest y value is -7. My value is 5. Yeah. Range means the smallest, largest. -2. Hey guys, what's the meaning of -2? Shift to the right by 2. What's the meaning of +5? Shift up. If the outside the bracket is up, down. Inside the bracket is left, right. But the inside bracket is opposite. If it's minus, shift to the right. Plus, shift to the left. Outside the bracket, plus, shift up. Minus, shift down. Terbalik. So this one I shift to the right by 2. I shift up by 5. And this graph, smiley face or frowny face? Answer, smiley. Now how do I know smiley? Your A, you look at your A. Your number in front is 1. Your A is 1, more than 0. It's a smiley face. If your number in front is negative, it's a frowny face. Now, another thing you need to take note is that, look at this, x is greater equals 2. That means I want 2 onwards. Anything less than that, I don't want. I don't want this. I want x more. So, when your x is more than 2, your y or your gx must be more equals to, what's the minimum? The minimum is 5. Yeah? So, it's greater equals to 5. Hello. Number one, you know you have to shift down by 1. So I know this one is negative 1. Now this one is just a sketch. I don't draw a perfect graph, but after all it's just a sketch. Okay, but I need to know when x equals to negative 2, what is your q value? So we can put negative 2 inside. You get 4 negative 2 square minus 1. Guys, this will be what? 16 minus 1, 15. As I put 3 inside, I got 4, 3 square minus 1. 3 square is 9. 9 times 4 is 36. 36 minus 1, 35. This is negative 2. This value is 15. 3 will be higher. When x is 3, your y value is 35. But always remember, this one I don't want to. Always remember, range means we are interested in finding the smallest up to the smallest to the largest. What's my smallest? Negative 1. What's my largest is 35. Okay. Yes or no? The first graph you need to know. Have you seen this before? 1 over x. Now 1 over x is a bit interesting because as your x increases, your y reduces. In your normal maths, you've learned this before. We call it what? Inverse variation. Heard before not? No, you haven't done variation yet. Normal maths. No. Okay, that means when your x increases, your y actually reduces. That's for positive part. For the negative part, it goes the other way around. Right? So, for example, when x is 1, your y will also be 1. When x is 2, your y is actually half. Right? But when your x goes negative, your y also goes negative. Number 2, what happens if you have a negative in front? Well, if your x is positive, now your y is negative. So we take bottom right, top left. Before this, we take top right, bottom left. Now we take bottom right, top left. Fair enough. Okay, what happens if I put a 2 in front? Again, actually the number in front, it doesn't affect the position. It does affect the shape. It doesn't affect the position of the graph. You don't shift left or right. It does affect the curvature, if you like. Like for example, when x is 1, your y is 1, right? Now, when x is 1, your y is, everybody? 2. Yeah? The position of the graph doesn't change. Okay, but it curves a little bit more, if you like. Looks like this. So if you don't want to like bother about number 3 and 4, it's okay, right? I just want to show you the difference. This is now like this, closer to x-axis. When x is 1, your y is what? Half. Sorry, it is ugly. Okay, number 5. What happened if I put the x minus 1? Now, this is something new. You shift to the right by 1, yes, but there is a line that you need to know. There's a name for this. We call it an asymptote. See before now? Asymptote. Asymptote, like when I give y equals 1 of x, right? Your x can take any value. Normally in your exam, right, they will say x, we write, have you seen this symbol before now? X is an element of real number. They put x cannot be 0. Because when x is 0, the graph goes to infinity. Siobhan, are you with me or not? Stop texting your boyfriend or your imaginary friend. No. So this one, your asymptote is at 1 now, right? So the graph cannot touch this line. It discontinues here. You see? Yeah? Okay? So number 6, what happens if you have an x plus 1? Now, you shift to the left by 1. So it goes top right, bottom left. Number 7 is very simple, 1 over x plus 3. Now, what is the meaning of this plus 3? I take this graph, I shift up by 3. By the way, actually you have 2 asymptotes. The first asymptote here, if I give you 1 over x, right? The first asymptote is at x equals 0. The second asymptote is at y equals 0. It's a vertical and horizontal line. But now that I shift up by 3, my asymptote stays here at y equals 3. So it's top right, bottom left. Number 8, if I give you 1 over x minus 3, now you shift down by 3. So this is negative 3, top right, bottom left. Can or not? Yeah. Okay, so that is number 8. I just show you one more example, number 9. So what if I give you, for example, 2 over x minus 1 a minus 3? How do we do this? Everybody shift to the right by push 1 and then shift down by 3. So you want to draw this dotted line, draw this dotted line, shift to the right by 1, shift down by 3, top right, bottom left. Okay. And number 10, I give you another example. How about y equals to 3 minus 2, you want to put 2, make it easier for you, 1 over x plus 1. Okay, this one means what? Instead of drawing, instead of shifting, drawing top right, bottom left, now I draw top left, bottom right. Okay, and then this is negative 1 here, right? And I have to shift up by 3 here. Everybody shift up by 3, shift to the left by 1, top right, bottom left. Okay, no. This is too difficult. Okay, I'm gonna, yeah. You last week, no, right? Last lesson, no. The graph, yeah. The square root, no. Yes or no? No. So how do you draw square root x? Square root x looks like this. This is the basic graph of y equals root x. Now again, why? How do I know? You know that y equals to x squared is like this, right? The moment you put x equals to y squared, it actually center around here. Yeah. So if I take this and one is a positive one. You know, when you bring over, there's a square root, and you got to put a plus minus. The positive is for the one above. The negative is for the one below. So this is the positive part. Now, how about the negative part? Well, the negative part is this. Okay. And number 3, what happened if you put a 2 in front? Actually, if you put a 2 in front, it just curve higher, faster. The gradient is a little bit higher. That's about it. It doesn't affect anything else. For example, when x equals to 1, your y here is 1. But here, when x equals to 1, your y is supposed to be what? Now, imagine if I put 1, square root 1 is still 1, 1 times 2 is 2. Correct? But if I put number 4, half of square root x, it is just flatter. When x is 1, your y is now half. Yeah, that is the difference. Okay, number 5. How about y equals to square root x minus 1 inside? Remember the minus 1? The number next to x is not going up and down, it's going left and right. Now, how do you know? How do you know? Or maybe you can do this. At x-axis, what is 0? Your y is 0. So square root x minus 1 is 0. X minus 1 is still 0. X is 1. So that means you actually start from 1. This is now your x-intercept. Now, if I give you square root x plus 1, instead of shifting to the right, now I shift to the left. Negative 1. Correct? Number 7. How about this? Square root x plus 3. The plus 3 means you shift it up by 3. The number outside is moving up and down. Number inside or next to the x is moving left and right. So I'm going to take this graph, I'm going to shift up by 3. So instead of starting at 0, this is 0 here, I start 3. And lastly, number 8, this is square root x minus 3. So you want to start from here, minus 3. Okay? Yeah. Now, I give you an example. Okay, how do you, number 9. So how do you do this? Square root x minus 1 plus 3. This one means, first, I shift to the left by 1. Then I shift up by 3. So it goes like this. 1, 3, is okay. Okay? Okay, number 10. How about this? Y equals to 3 minus square root x plus 1. This is interesting. The negative here means you reflect down on the x-axis. Okay? Then plus 1 means I shift to the left by 1. There's a 3, means you shift up by 3. So it looks like this. Shift to the right by 1. shift up by 3, but instead of going upwards, it goes downwards. Yeah. Now, why must we do all this? Because you need to know, if you can sketch a graph, you can find a range. Now, look at this. I'm supposed to shift to the left or right? Come on, left or right? Right by 4. Then I shift up by 3. So my graph looks like this. Shift to the right by 4, shift up by 3. This is positive, so it's going upwards, and so on. Now, how do you write the range? How do you find the range? Now, so happen your x is greater equals 4. That means your domain is here. This is your domain. Domain represent your x value. Range represent your y value. But this one goes all the way to the positive infinity. Yeah? Correct or not? It goes to positive infinity. So this graph goes all the way to, your y also goes all the way to positive infinity. So how do you write your range for hx? Your smallest value you can get is 3. The rest should be greater equals 3. Okay. Now I'm going to do part by part. Just do part A first. Can you do self-test A now? Self-test. Okay. Now, like I say, the first thing you want to be doing is to put. Remember, negative square root x means equal downwards. Negative square root x plus 2 means I take this one, I shift to the left by 2. So this is negative 2. Then negative square root x plus 2 plus 5 means I take this one, I shift it up by, everybody shift it up by 5. So when I shift up by 5, my graph looks like this. This is now 5. But here's the thing, your domain is from minus 2 to 2. I already know at minus 2, my y is 1. How about at 2? At 2, I can put 2 inside. I'll get 5 minus square root 2 plus 2. 2 plus 2 is 4. Square root 4 is 2. 5 minus 2 is 3. This is 2. This will be 3. So what is your range now? Remember, range represents your y value. The smallest value of y is 3. The largest value of y is the largest value of y is 5. So what do? You can write fx is between 3 and 5. Okay, another way of thinking is that guys, if you understood the type of relation, right? You don't want to draw the graph also can, right? Remember what I say, when is a one-to-one relation? Everyone, if it's a one-to-one relation, do you have turning point? No turning point. Do you know that? Hey, if it's many to one, you have a turning point, right? Remember we talked about this last lesson? Yes? No, don't remember. We talked about this last lesson, right? So if it's a one-to-one relation, let's say I don't want to draw a graph. I just put the limit minus 2 inside. 5 minus square root minus 2 plus 2. This will be 5. Then I put 2 inside. 5 minus square root 2 plus 2, I know this is 3. So I just plot my graph. I know minus 2, 5 is here. 2, 3 is here. I know it's a one-to-one. So one-to-one, it doesn't change direction. So that means the smallest value is 3. Largest value is 5. So you can straight write 3, 2, 5. Yeah, for one-to-one relation, it's safe. You can just plug in a value, get this 2, then know this is the smallest, the largest, just write this. Don't even have to draw the graph. Okay? But many-to-one relation cannot. Yeah? But I would still recommend that you know how to draw the graph, simply because sometimes your range is this. Can you see? Your domain is this. Greater equals 4 means what? It goes from 4 to infinity. So how do you know where the graph will go? Right? So that's why you have to sketch it. Yeah? I mean, it's better to know how to sketch it. Alright, this question a little bit different. Because you have a 3x plus 2. Okay, everybody, what is the meaning of 3x plus 2? You shift to the right by how many? Or left, right or left? Okay, can I just let this be 0? Your x is negative 2 over 3. So this x value, we always let the denominator be 0 and solve for x. This x value represents your, start with letter A, what do you call it? Asymptote. Very good. Asymptote. The keyword is asymptote. So that means I'm going to take this and shift to the left by negative 2 over 3. So by right, we should draw top right, bottom left. Now, however, look at this. This is easier because they already mentioned, what is this? Your x should be to the right, the domain. So do you take the left hand side one? No. So if I look at this, right, what is my largest value of y? Think again. It goes all the way up. All the way up means it goes to infinity. Do you know it goes all the way up? It goes to infinity. What's your smallest value of y? It goes down all the way to where? No, can it go negative now? Cannot, right? It goes to 0, am I right? As my x goes to infinity, your y goes to what? 0. It will never go below that, right? So how do you write your range, guys? Your range is your y value. Remember, your kx can be 0, cannot be 0. It goes from, now how do you write this? Do you write 0 kx infinity? No, right? We don't write like this. So we write kx greater 0. By the way, can it be 0? No. It will be only 0 when x approaches infinity. So we cannot write equal 0. We say it's more than 0. Okay, can you draw this graph now? Your self-test? Yeah? Let me explain. Again, I hope you understand the idea of asymptote. For this type of function, we let the denominator be 0, your x is half. So this is your asymptote. So we know we have to shift to the right by half. We take top right, bottom left. However, like I said earlier, they want your x value to be between 1 and 4. So what we can do is we can put 1 inside. 7, 2, 1 minus 1. Answer will be 7. If I put 4 inside, 7, 2 times 4 minus 1. Answer will be 1. That means when x is 1, your y is 7. When x is 4, your y is 1. So this is your range. So we can say that gx is between 1 and 7. Okay? Concept of one-to-one relation. We know exponential function is one-to-one relation. So what we do is we sub in these two values. When your x is negative 2, you get negative minus 2. What is this? 9, right? When your x is 3, 3 power negative 3, 1 over 27. So we can do a rough sketch. When x is negative 2, 1 over, it's 9 over here. When x is positive 3, you get 1 over 27, which is somewhere here. So I know it's a one-to-one relation, so it goes like this. Cannot. So you don't want to remember the shape or why the graph is going upward. So what's your range? Your f 1 over 27 and 9. Okay. Please do self-test 7a. Okay, again, if you put 0 inside, you get 5 power 0 plus 1. This will be 1 plus 1, 2. If you put 2 inside, you get 5 power 2 plus 1, you get 26. So I know this is 0, this is 2, this is 2, this is 26. So the graph goes upward like this. So this is the smallest value, this is the largest value. So my range for gx should be between 2 and 26. Okay, not difficult, right? How about this? You shift to the right. Okay, this is a cubic function. This function is a bit unique. Again, I explained the graph for you, but if you don't want to know the graph, it's okay. Because cubic function, remember, I don't know whether I told you this at the beginning of the chapter. I think I did, right? What type of functions is this? What type of relations is this? It's a one-to-one. So one-to-one, we just plug in the value. Take the smallest, the largest, we sub in, then we know the minimum maximum. You don't have to really know how to sketch a graph. But if you want to know, okay, let's say, what happens if I minus 1? Do you know? The minus 1 means what? Shift to the left or shift to the right? To the right by 1. So, it's not an asymptote, it's just cut 1. Now, let's say I give you x minus 1 cubed, then you plus 3. You move up by 3. So you move up by 3, this is 1, this is 3, this is a point. You get, whoa. That's how the graph looks like. Okay, but again, like I said, if you don't want to know the graph, you know cubic function is always a one-to-one relation. So we just plug in the value, put 0, -4. So we can tell that the largest value is 12. That's it. Like if you want, you can sketch this. This is move 2 to the right, 4 up. The graph should look like this. 0, this is -4. And when x is 4, this will be 12. If you wanna, if you don't want to draw this, is fine. Yeah, sorry if the graph looks a little bit ugly. Oh no, it's getting worse. Okay? Okay, that's all. Come, hurry up, self-test. So the first thing is we sub in -1. Guys, if I put -1, what do I get? 27 minus -1 cubed. So it's 28, right? If I put 3, I get 27 minus 3 power 3. 3 power 3 is also 27, right? So what do I get? 0. So you can say that the smallest value we get is 0. The largest value we get is 28. So we write hx between 0 and 28. So guys, if I were to sketch this, if you really want to know how, x squared, x cubed means like this, right? Negative means the other way around. When you have a 27, means you shift up by 27. So the graph, oh, did I make a mistake? Oh, no, I didn't. So the graph looks like this. This will be 27 here. If you put -1, this is 28. If you put 3, it should be 0. That's why your range is between 0 to 28. It looks something like this. But if you don't know how to sketch, it's okay. Just submit. Yeah, it's easier.